Good day, Sir Ryan. My name is Nina Pascasio from DCET 32, and this is my reflection video about AWS Cloud, or what we call Amazon Web Service Cloud. Cloud. Cloud let us rent the services that we need and use only those services that need. So it ended up paying for the services that we rented, and it ended up saving a lot of money. The other thing is these services providers take care of all the issues like security, underlying infrastructures, and all those things, so we can really focus on our business and stop worrying about all those issues. In simple words, it's a huge space which has all these services available, and we can just go ahead, pick and rent those services that we want to use. Cloud computing. Cloud computing is a place where we can store our data, process the data, and access it from anywhere in the world. Cloud makes the world accessible. It lets us have our applications wherever we want to and manage them the way we want to. There are three different service models. The first one is software as a service, the second one is platform as a service, and the last one is infrastructure as a service. SaaS, or software as a service, is we're just consuming a service which is already handled and maintained by someone else. For example, eating a burger, and then there are various ways of doing that. Once you order it online, you sit at home, you order the burger, it comes to your place, you consume it, or in short, you just consume the service. PaaS, or platform as a service. Here, we are provided with a platform where we can go ahead and build our own applications. For example, your platform as a service, you can think of it as going to a hotel and eating a burger. You go there, they have the infrastructure, as in you have the tables, chairs, you have to go sit, just order the burger, it is given to you. You consume it and you come back home. And then IaaS, or infrastructure as a service, the whole infrastructure is provided to you so that you can go ahead and create your own applications. That is, an underlying structure is given to you. Based on that, you can go ahead and choose your operating systems, the kind of technology you want to use on that platform, the applications you want to build, and all those things. This is where you go ahead and make your own burger. You have the infrastructure, you buy it from somewhere or whatever it is. You use your burger, you put it in R, and you put ingredients, all those things, and you eat it. Infrastructure. Cloud infrastructure is a collection of the components and elements required to provide cloud computing. It includes computing power, networking, storage, and an interface that enables users to access virtualized resources. Virtual resources mirror those physical infrastructures and include components like memory, network switches, servers, and storage clusters. They are required to create applications that users can access through the cloud or retrieve via the internet, telecom services, and wide area networks. The cloud infrastructure's approach offers benefits like greater flexibility, scalability, and lower costs of ownership. Cloud infrastructure enables organizations to access data storage requirements and computing capabilities as and when they need it, rather than creating on-premise IT infrastructures or leasing data center space. Organizations can now rent cloud infrastructure and the required computing capabilities through third-party providers. Cloud infrastructure is available for private, public, and hybrid cloud systems. It can also be rented through cloud providers and via several cloud infrastructure delivery models. Components. There are cloud components such as AWS EC2, AWS Foundation Services Database, AWS security, and etc. Elastic Compute Cloud, or EC2, is a web service which aims to make life easier for developers by providing secure and resizable compute capacity in the cloud. It is very easy to scale up or scale down the infrastructure based on the demand, and not only that, this EC2 service can be integrated well with almost all the services in Amazon, and the best part could be is that we only pay for what we use. Database and AWS. There are a host of options to store the data by using multiple database services in AWS. So quickly speaking, we have RDS, the relational database service that supports many engines. Then there's an offering from AWS that is known as Aurora. It is a fully managed MySQL compatible relational database service. Then we have a NoSQL service offered from AWS that is a fully managed service as well. It is called DynamoDB. Then we have Redshift, which is a petabyte level data warehousing service. It is a fully managed service. Then we have Elasticache that supports in-memory cache to very popular engines such as Memcache and Redis. Then we have a very cool service called Database Migration Service that basically allow us to migrate our database from Oracle to Aurora. We can use the service, and then there is no downtime at all when we use it. Security at AWS is job zero. That is what AWS talks about. That is everybody's responsibility, and it starts right from the infrastructure. We spoke regions, we spoke about availability zones. So availability zones are the physical data centers, and they are designed to be fault tolerant. They are designed to be highly available, so they are always in a group of 2 or more, so that way if one goes down for any reasons, we will still have the services running from the second data center. AWS has something called the Shared Security Responsibility Model, where they say that whatever happens to the underlying infrastructure, they are responsible for securing that infrastructure, such as the regions, the availability zones, the edge locations. They are responsible for that underlying infrastructure. The customers are responsible for everything that they put on top of that infrastructure. So the data, the application, the access to firewall rules, the customer is responsible for configuring access to anybody on that infrastructure by default. AWS provides all the tools, and they do not provide any access to a firewall that we create, any users that we create, or any object that we upload to the cloud by default. It will be private, so we have to explicitly make it public for any users. We have to give them permissions to do something, otherwise they will not be able to do anything. Whenever we add any data, then it is address we have to tell them who can access it. AWS gives you a whole set of services to secure your data, to secure your applications, to secure your resources such as servers in the cloud. Pricing models. There are 3 pricing models. The first one, pay less as you get more. The second one is pay as you go. And the third one is save when you reserve. Pay less as you get more. Yes, the more services we use as far as a device is concerned, it charges us fairly less. We have a chance of saving up to 70% of our total cost, and that is a very nice feature to have. Pay as you go. The database has a very flexible pricing model. Now, what do I mean by this? Interest charges daily plus. It charges us only for the compute capacity and the resources which we are using. So if we need a particular resources for 1 hour, and we need in the number of hour, in the amount of computing capacity, we're just be paying only for the thing. For example, our requirement is 40 gigabytes. for the first month, but what happens is we end only using 10 gigabytes. Now in this case, our 30 gigabytes of space is wasted, and this is when we pay a friend. But if we pay daily basis and only for the resources which we are using, we're actually saving up all the costs with us would otherwise pay. Save when you reserve. Now, if you know how much resources and the compute capacity you are going to use in your future, what you can do is you can go ahead and reserve these services in advance, and in that case, AWS charges you fairly less compared to the other models. So let us go ahead and take a look at this one by one. Firstly, we have no upfront cost. Now what this means is you can go ahead and reserve your resources and your services in advance, but you are not paying anything. But what happened here is you are paying an amount which is lesser than the previous two mentioned models that are paid as you go and pay less as you get more. But this thing is still costlier compared to the other subtypes of this model. That is the partial upfront cost and full of upfront cost. Now, going to talk about the partial upfront cost, you are paying a partial lump sum amount which is less than the total amount, and you are reserving all your instances and all those things, but this is comparatively affordable when you compare it with no upfront cost. It is, however, costlier than the last one, that is full upfront payment or cost. In the last point, that is full upfront cost, what you do is you decide, these are the number of resources which I am going to use, and this is computed capacity which I need, and accordingly book all those resources and you make an upfront payment. Since you are making an upfront payment, this is the most affordable of all the pricing models that are there, but for this you need to be assured that these are the minimum resources that I am going to use, and if required I will have to scale up but not scale down. This is about different pricing models as far as the device is concerned. And then let's proceed to the advantages of using cloud. We all know that everything is going online these days. That's why we have the chance to shop online with almost everything that is required as in whatever information we need. We get everything online, our reservations, our booking, everything can be taken care of. We have a lot of data that is being generated these days, and this is digital data, but before we were communicating through verbal discussions and all those things, so through paperwork, and that was a different data to maintain. Since everything is moving on cloud or moving online, the amount of data that we have is used these days. And then when we have this huge amount of data, we need a space where we can maintain and go this data. So yes, again, there was a need for this space, and all these issues that are costly and monitoring our maintenance, providing sufficient space, everything was taken care of by cloud. First advantages: cost savings. Cloud computing eliminates the capital expense of buying hardware and software and setting up and running on-site data centers, the racks of servers, the round-the-clock electricity for power and cooling, the IT experts for managing the infrastructure, and it all adds up pretty quickly. Second, the speed. Most cloud services are provided self-service and on-demand, so even vast amounts of computing resources can be provisioned in minutes, typically with just a few mouse clicks, giving businesses a lot of flexibility and taking pressure off of capacity planning. Third, global scale. The ability to scale elastically and cloud speak, that means delivering the right amount of IT resources, for example, more or less computing power, storage, bandwidth, right when it is needed and from the right geographic location. Fourth, productivity. On-site data centers typically require a lot of racking and stacking, hardware setups, software patching, and other time-consuming IT management tools. Cloud computing removes the need for many of these tasks so IT teams can spend time on achieving more important business goals. Fifth, for performance. Biggest cloud computing services run on a worldwide network of secure data centers which are regularly upgraded to the latest generation of fast and efficient computing hardware. This offers several benefits over a single corporate data center, including reduced network latency for applications and greater economies of scale. 6. Security. Many cloud providers offer a broad set of policies, technologies, and controls that strengthen your security posture overall, helping protect your data apps and infrastructure from potential threats. 7. Mobility. Cloud computing allows mobile access to corporate data via smartphones and devices, which considering over 2.6 billion smartphones are being used globally today, is a great way to ensure that no one is ever left out of the loop. 8. Sustainability. Given the current state of the environment, it's no longer enough for the organizations to place a recycling bin in the break room and claim that they're doing their part to help the planet. Real sustainability requires solutions that address wastefulness at every level of a business. Hosting on the cloud is more environmentally friendly and results in less of a carbon. And then let's talk about agile development process and how it is used in modern technology development. Agile development is a methodology. It's not a tool. It's not an exact way of writing requirements. It's not an exact way of communicating. It's a whole methodology. It is a type of project management, but really, it's a way of working as a team. Agile is a way of executing software development project management, so it's a project methodology. Second, Agile is iterative. This means that we go in tight cycles. We'll work for a while and then we'll see we get and then we'll revisit all the plans. Make as many changes as we want and start again. Those are usually called sprints or iterations. Those could be a weeks or 2 weeks. This is total opposite of the waterfall technique, where we write a gigantic specification and everybody works away on it, and then you get it assigned by the client and then you build it to it like a blueprint. It's like a building, a high-rise building. Once the blueprint is done, you don't make any changes. That's the waterfall technique. Agile is a total opposite. We revisit the plan constantly, so we do tight iterations. Iterations is a huge concept in Agile. Third concept, Agile is very streamlined. When we do Agile development, we really favor getting to work and digging in and doing stuff, as opposed to having tons of documentation and a million meetings and all the preceding overhead. So in Agile, we have a lot of quick meetings. We favor short, tight documentations over huge documentations. We don't have a million milestones and ton of process overhead. We're very streamlined. We want to move fast. And the last concept is time boxing. The term time boxing really just means that we're going to plan our work by time instead of by futures. And this is a concept that takes time to get used to. In most projects, we'll say we want to do feature A, B, and C, and we're going to do them in that order. And we're going to try to get them done in 3 weeks, but we'll try to get them done in 3 weeks, but we'll see if we can possibly do that. We're definitely going to do those features in Agile with time box. We do it in the opposite way. We say we're going to 3 weeks of development and we're going to try to get features A, B, and C. We're rigid on time, not on features. If halfway through we get it all done, That's great. Let's add in future D. Let's keep working because we plan 3 weeks work. Agile is usually very collaborative in an agile project. Everybody is talking to each other all the time. It's a fast moving thing. We don't disappear for 2 weeks and come back with a finished product. So those are the key points about agile. And then finally, let's talk about DevOps in modern technology management. DevOps integrates operation teams and developers to improve productivity and collaborations by automating workflows, automating infrastructure, and continuously measuring applications' performance. DevOps teams try to automate everything from testing of new code to how infrastructure is provisioned. DevOps team enable to adapt an iterative process to monitor, measure, and improve the code and operations every day. The DevOps-oriented team would do is to use a source control system to help document and manage all of the changes to both the configuration management code and application code. And that's all. Thank you.